Hello everyone, welcome to the verification lab. This is the first video in our practical series where we will transform all the theory we have learned into real and hands-on implementation. So this API is known as EDA Playground. Just go to the Google, search EDA Playground, log in with your Gmail account and you will be forwarded into this page. So you can see there are two classical division. So one is test bench and one is design. So design is where we write our article code and test bench is place where we write our test bench code. Apart from this, we have to go through some of the important options in the API. So language and libraries, you have to select SystemVerilog, Verilog. There are many options. So you have to select the SystemVerilog and Verilog. And in the tools and simulator section, you have to select the commercial tool and Rivera Pro. Rest all are only accessible by organizational email, but don't worry, if you don't have an organizational email, with normal Gmail you can have this Eldec Rivera Pro, by which we can do almost all the works of a design verification. So let me choose this. Now it is our first program, so let us give us a name so that later if you want to access and see again what we have done, so you can access it. So first program, this suits our purpose, so let me save this. So I will start writing our test bench. So basically you can write standalone test bench also. If there is no design, we can run it perfectly fine. There is no issue. So we'll start with the keyword module. We will put an identifier. So identifier name is user defined. Keep it as a name which resemble the functionality of your test bench. And I will end this with end module. Now in our theory session, we have gone through many data types. So among these, one is bit. So I will take one example with bit. So I have taken bit. It is an user defined vector size. So you can choose it. So as of now, I am choosing it 8 bit. So 7 down to 0. A. So basically, I have taken a variable and it is of a bit type and the size is 8 bit. Now let us store some value. To store some value and display some value, the thing would be done in a procedural manner. For that, we have a construct initial. Though we have multiple statement, we have to use begin and end. So what this basically does, this construct basically does is that initial execute one time and begin and execute sequentially in manner. All the program we write in our SystemVerilog test bench or HDL, those are concurrent in nature. So to have a sequential execution, we have to use some special keyword, and this block are known as procedural block. The keyword begin and end if we have multiple statement. So basically let me store some value. So as of now I am storing value to our a. So I am storing here. So I am taking the size as an 8 bit and I am storing here 5. And now let me display the value. So to display the value, we will be using system task that is display, that is present in our Verilog. So we can write some meaningful string so that when you get an output, we can link everything to it. Now we will give the format specifier. So it specify in which format you want to print the data. We have many options. One options among them are decimal. All set, all done. Now let us run this. So before run, we can save this. Now let me run this. So you can see the value of A is 5. So we have seen that we are printing the value, storing the value and printing the value. Now let us do some more experiment with that. So basically I have told you there are many format specifier. So D for decimal. So let me change it to binary and let me run and see what the output is. So you can see it is 101. So in the decimal equivalent, binary equivalent of the decimal number 5 is 101. So we are getting the pin. So similarly, if you want hexadecimal, just remove this B and press H. So you will get hexadecimal for octal O. And one more information like I want to say is that like earlier we use B for binary, so it is small letter. Now if you use capital letter, it will also work fine. Let us run this and see the output. So here it is very clear that 101. Now let us talk about the state. So we know in SystemVerilog we have two-state data type as well as four-state data type. Two-state that can store 0 and 1, four-state 0, 1, X and Z. Now what will happen if we try to store four-state value into two-state data type, two-state variable. So A is a two-state variable. Let me store a four-state value that is unknown and let me print the value and let's see what is happening. So you can see the value is unknown, but we are getting 0. So what is happening? The default value is getting printed and assignment is nullified. So we cannot store same thing. But let us say we want to store. So what we will do? We will change the data type. So let me comment this out. And we have a data type known as logic. It is a four-state data type. And let me run this. So you can see the value of A is all are unknown. That means it is properly assigned. So basically four-state data can hold X and Z where two-state data cannot hold. And the practical implementation I have shown you. Now let me move to the next examples I have. So basically we have a bit, it is 8-bit width and we are storing 5. Now let us store a negative number. So let's see if it can store or not. So let's take a small number 1 and here the sign is negative. And as we know that our bit is a unsigned, so it cannot store negative. Let us store the negative and see what result we are getting. So you can see we are not getting 1, but somehow we are getting something different. So why we are getting this? So I will explain you this. In computer system, whatever number we are giving, negative number, it is stored as a 2's complement. So let us see. So we have a number. So it is like this. So what is the 2's complement of A? This number. So first we will do 1 complement. So if you do 1 complement, this will be like this. After that we will add 1. So if we add 1, so this is the 2's complement representation of -1. So we are getting those value and it is not correct because MSB stand for sign and we cannot have a sign. So we are getting the maximum value. So it is basically, if we see the decimal equivalent, we can see it is 255. So it is 255. So we cannot store. Now what to do? So we'll use byte A. So byte is basically a sign and I will comment this out. And we are storing 1. Now let's see. So you can see here, we can store negative number in a signed data type only. Unsigned data type will give us a different values and like it is of no use. So to store signed number, you have to use signed variable. Now let us do one more experiment. Now let's say this bit 7 down to 0A is defined somewhere else. and we want to find the size of the A. So how will we find? So there is a formal way and an informal way. So first I will go for the informal way. So I will change this thing here, the size of A percentage 0D, and I will use standard method, and I will run this. So you can see the size of A is 8. So we have got our size. And now what is the informal way? So let's discuss the informal way also. Just we will remove the 0 from here, and I will print it is in binary. So the number of bit here represent the size. So here is 8, so we can say that size is 8. So this is an informal way. So formal way is also always appreciated. So this is the end of our today's session, and if you found value in it, please like, share, subscribe to the verification lab, and let me know your thought in the comment, and I will see you in the next one. So that's all. Thank you.